Welcome back, everyone. We've got a fantastic explainer for you today. You know, we spend a lot of time marveling at the finished products of modern AI, but today we're going behind the scenes. We're looking at the hidden supply chain. How is all that raw data sourced, structured, and most importantly, actually valued? Well, let's dive right in and explore the fundamental architecture of AI data, looking specifically through a framework called Codatta.
And that brings us to a really massive question. Who actually owns the data powering AI? For the longest time, AI data has been this giant black box. Millions of people are contributing out there, labeling images, writing text, grading AI responses, but how do those creators actually get paid for their specific contributions? How do you even track their work once it's swallowed up by some massive algorithm? Well, that exact problem is what the Codatta architecture is designed to solve. So here's our roadmap for today. First, AI data building blocks. Second, quality data for better models. Third, Codatta's atomic data model. Fourth, real-world data scenarios. And finally, the power of assetification.
Starting with Section 1, AI data building blocks, the atomic elements of AI.
Okay, so before we can even talk about global data economies or blockchains, we've got to get down to the absolute smallest elements of AI data, the foundation. And it all begins with the sample. In math notation, you're usually going to see this represented simply as X. Basically, a sample is the absolute raw, unrefined material of the AI supply chain. Think of it as a pure observation that the model is going to learn from. It could be an image, maybe a short audio clip, a specific snippet of text, or even a time series window from a bunch of sensors. On its own, it's just raw information, sitting there waiting to be understood. And that brings us to the label, which is mathematically noted as Y. If the sample is your raw material, the label is the human interpretation that snaps perfectly onto it to actually give it meaning. It's a structured interpretation. So this might be assigning a class to an image, like, hey, this is a picture of a cat. Or it could be drawing a bounding box around a stop sign for a self-driving car, or maybe providing a quality rating. The label is quite literally what teaches the AI what it's actually looking at.
To complete our little dictionary here, we have validation. This is the absolutely crucial quality control step in the whole data assembly line. A validation is simply a quality judgment or an evidence check on a sample or a label. Because, how do we know the labeler actually got it right? We validate. This can be consensus voting among a group of people, rubric scoring, or even automated checks that humans look over later to adjudicate.
Moving to Section 2, Quality Data for Better Models. Why good data matters.
So why are we obsessing over the meticulous quality of these little building blocks? Well, because the quality of these elements completely dictates whether your model succeeds or fails. First off, high quality reduces noise. Mislabeled or low information data literally slows down the model's learning process. Second, rigorous quality prevents things like bias, inconsistent schemas, and label leakage, all the bad stuff that really harms an AI's fairness and ability to generalize. And third, for these complex chain-of-thought models we're seeing today, you absolutely need clear instructions and traceable provenance to be able to debug the system. Basically, better samples and clearer labels mean far fewer nasty surprises when you finally push your AI into production.
All right, Section 3, Codatta's atomic data model, organizing the chaos.
Let's look at how Codatta actually takes all these messy, disconnected concepts and organizes them into a super trackable system. It's essentially a three-step escalation. Step 1 is the atomic contribution, or AC. This is a single unit of work by a human or agent, so the sample, the label, and the validation all tied together. Step 2 scales that up into a data asset, or DA. This is your minimal commercial unit created by aggregating those atomic contributions that belong together. And finally, Step 3 is the data set. This is the big, curated collection of those data assets put together for a specific model evaluation. Let's zoom in on how this tracking actually works.
The secret sauce making Step 1 possible is something called the Contribution Fingerprint. Every single atomic contribution gets one of these. It's a tamper-evident identifier. It uses a cryptographic hash, metadata, and parent links. This fingerprint proves, without a shadow of a doubt, who did what, exactly when they did it, and to which specific payload. Because of this fingerprint, every tiny piece of human work becomes discoverable, deduplicable, and entirely auditable. Your work literally cannot just get lost in the machine.
Scaling up to Step 2, here's the absolute most crucial takeaway. The data asset is the minimal unit of ownership, licensing, and royalty. Why does the specific level matter so much? Well, because the data asset is what AI buyers actually consume. Think about it. AI teams aren't out there buying one single label. They buy the composite asset. So ownership and licensing have to be strictly enforced right here at this asset level.
Section 4, Real-World Data Scenarios, the Supply Chain in Action.
Okay, Let's shift from theory to practice and look at 3 scenarios where this architecture really flexes its muscles. In scenario A, we've got multiple label sets. Here, one single raw sample, say a photo of a busy street, gets labeled for 2 entirely different tasks. It gets bundled into different assets depending on the label. This matters because that one raw sample can power entirely different AI products, and each generates separate royalties. Pretty cool, right? Then, scenario B is a cross-sample composite. Think of a back-and-forth dialogue or maybe video clips. 2 samples are combined and labeled as one unit. Codatta keeps all those complex derivation links perfectly intact for attribution. And finally, scenario C is meta-labeling, where a downstream label targets an upstream label.
I really want to pause on this because that fact from scenario C is just wild. Meta-labeling means AI is actively learning from humans who are judging other humans' labels. You're not just annotating a raw picture, you are annotating human interpretations, like giving a confidence score or an evaluator note on someone else's work. And thanks to those contribution fingerprints and data assets, the royalties can actually dynamically propagate through all these layers. The meta-labelers get paid and the original labelers get paid. It's all handled through clear revenue inheritance.
And that brings us to Section 5, the power of assetification. Blockchain meets AI data.
So we need to bridge the gap between this beautifully structured data model we've just been talking about and the actual network governing it all. Traditionally, data labeling just spits out files that are incredibly hard to track or value accurately. But assetification completely flips the script by turning human work into on-chain objects. It gives those files programmable rights and verifiable lineage. We get provenance through those fingerprints. We get actual ownership via fractional tokens on the data assets, so multiple people can share revenue. It enables licensing and metering, meaning usage receipts drive the royalty routing. Derivation rules carry inheritance automatically. And crucially, it features privacy by design, using secure computing so AI models can train on the data without exposing your raw underlying content to the public.
To really summarize the blockchain advantage here, it boils down to 3 main pillars. First up, trust minimization. We're talking about a public, append-only record of contributions. You don't just have to take some massive corporation's word for it anymore. Second, composability. You can seamlessly query, bundle, and relicense these assets across different apps while keeping their lineage perfectly intact. And third, incentives. This system finally aligns data quality with long-term financial value, making sure contributors and validators actually earn money when their assets are utilized by the models. Which brings us to our final thought for this explainer. If every single data point, every sample, every label, every validation can generate traceable royalties, how is that going to change the entire economy of human knowledge? We are literally moving from a world where our digital exhaust is just harvested for free into an architecture where every atomic contribution has a verifiable, monetizable fingerprint. It's a massive shift in how we value human intelligence in the age of AI. Thank you so much for joining me today to unpack all of this. Keep exploring, keep learning, and I'll see you in the next explainer.